Hello everybody, welcome back. It has been a while, but I'm back, so let's do something fun. Today I would like to use a time of flight laser ranging sensor, so something that measures distance until something solid. And you can use it yeah, it's often used in drones or in parking sensors, that kind of stuff. It measures distance, and I would like to do that with my ESP32, and I would like to do it in Rust. So first we need some hardware. So having a quick look at Amazon shows, for example, this one, the VL53L0x. Don't know much about it, but let's look at what it looks like. So we have a little board with some stuff on it, and that's all I know, and that's enough. So how do we wire this thing up? This is a Arduino example, but for wiring that doesn't matter. So we need to connect 4 wires. We have 5-volt and ground, and we have 2 pins. I think the voltage range from these sensors are pretty broad, so you can also connect them to 3.3 volt up to 5. And the ground, and we need to just use 2 GPIO pins. So that should not be a huge challenge. What's next? What do those pins mean? Because it says, so you have the power and the ground again. Yeah, it kind of sucks. This resolution is a little bit tricky. So we have the two, we have the power supply and the ground, and then we have 2 I2C serial lines. So the first the clock line, the second is the data line. I2C is a intercomponent serial bus, in a sense. Bus in the sense that we can connect more than one component to the same pin. So if we would have 2 or 3 components, we could all connect all the clock wires to the same pin and all the data wires to the same pin. And then whenever we want to talk to a device, we need to address it, and every device has an address, and the address is a 7-bit number, I think. So you can theoretically have up to over 100 components on a line like that. I never tried it, and we're also not going to try today. Today we have only 1 component, so that should not be a problem. Finally, there's a programmable interrupt output. I didn't get it to work. I'll get to it at the end. Exercise to the reader, or maybe we'll figure it out while doing it, who knows. And there's also a shutdown. I think you need to put it low if you want the chip to ignore your requests. So you can use that to, even if you have multiple with the same address, you can periodically switch one of them on or off, I think. So the last 2 we're not going to use, we're just going to use the 4. Let's have a look at our wiring. So this is what I did in my signature beautiful wiring. We have our, where's my pen? Here. So we have our small form factor ESP32, and we have the rangefinder right there. And we put here on the rail we have plus 3.3 and ground, and we connected that to the right pins here, and we connected these 2 to pin 8 and 9 on the ESP32. So that's all for hardware, I suppose. So we want to do some Rust, so let's see what we can find. And this component has a Rust crate, which is very fortunate, because that saves us from having to figure out how to do the actual yeah, figuring out how exactly it would work in I2C. No, I want to see the crates, which is always a bit of a let's have a look. Where's the crates? Yeah, here. So it is a no standard driver, which is good. Looks something like this. We create this object. We give it the I2C object. We unwrap stuff, and then we should be able to configure it a little bit and then start measuring. So far so good, so let's get to coding. Let's do an ESP template. Let's call it ESP32 LiDAR C3. Advanced, why not? Alloc, yes please. No Wi-Fi, that makes the whole flashing and compiling a bit quicker. We don't need dev contains, we don't need workwe, GitHub action. Oh, why not? Okay, let's run that and see speed to LiDAR code. Okay, I have connected the board, so let's see if we just do a cargo run. It detects the device, which is good. And it says hello world. So that's nice that this part is so easy nowadays. I remember when I started my channel about a year ago, that was a whole lot more involved getting stuff right. So I'm glad it got easier. So, we need to do some stuff. Let's start by configuring the I2C. So we need to create an I2C object with the device driver, let's call it that, and pass it on to the driver of the LiDAR. Okay, so let's see. Before we do that, we need to have our pins, and the pins we create an I/O object for, like we have done in pretty much every project we did. It's exactly the same. We do I/O new, and what does it need? We need to import this, and this needs GPIO and I/O mux, indeed. So that's in peripherals, GPIO, and peripherals I/O mux. So now we have I/O object. Let's create the I2C object. I2C, C, I think. Let I2C that. Yeah. New. So here we see some things that need to get into that. So the data and the clock line, frequency, clocks, and ISR is interrupt. We're not being using that. So this will be a peripheral, I think. I2C0. I think it's the only one for a C3 board. SDA, that will be I/O pins 8, GPIO 8. And this one will be IO pins GPIO 9. Frequency, I haven't really noticed an awful lot of difference between the frequencies. This one seems to work pretty nicely, so 1 megahertz, but I don't think it matters very much for our case. Borrow the clocks, and interrupt we're not going to need, and it's an option, so we can just say none, and then it's all good. So now we have an I2C object, a blocking one. Let's put it after the logger, does not matter. Now let's have a look at our custom crate. So this is basically what we want to do. Let's copy it and add it here. Okay, let's see if we can instantiate one of those. Let's call it sensor is this one, and then new, and then we pass in the I2C. So that seems to work. Oh, we need to unwrap it or something. Okay, so far so good. Let's sensor sensor. It seems to miss all its things, and I think it's this is a Rust analyzer thing, because if I show the types, it does show that. So I think it will help if we just make a type annotation. So we say VL thingy I2C thingy, and then I forgot. It's always tricky to remember what it said. I2C 0 and blocking, okay. I2C 0 and blocking. Okay, so now it has an official type. Let's see if the Rust analyzer works. Yeah, now we can do things, so that's nice. So there are a bunch of methods here. Not all of them are documented. This is, for example, this is the address. So we can use that to address different chips on the wire, but ours is at 29 hex, and that's the default one, so we can just ignore it. So this one looks pretty straightforward. Read range, continuous millimeters, blocking. So let's see. Distance, see if that works. The sensor needs to be mutable, not a problem. And it's a result. Let's unwrap it. And that returns a U16. So let's see if that actually works. So we put it in the loop, and we say, instead of hello world, we say distance, and we include that distance. All right, let's see what that does. Cargo run. Let's include the camera here. Just move this up a little bit. And let's go. That didn't work. I think we need to do a little bit more configuration for this one. So I think what happens is that the default budget is maybe incorrect. Let's see. So sensor set measurement timing budget in microseconds. So let's try this one. And try again. What could be wrong? This looks okay. I can increase that. Let's see what this does. No, I do think there is something missing. Pin 8, pin 9. I don't really see what is wrong here. Let's read this a bit more carefully. Line 41. Maybe we should be a bit more forgiving than just unwrapping it. Let's do it like this. Let's just see if there is a distance. We will do this, and otherwise we don't, we ignore it. Let's see what this does. It seems to consistently fail. Let's see if there maybe the wires got spooked a little bit. I'm not sure. It seemed to always fail because it didn't print anything. So let's maybe replug it. Would the frequency be a problem? I'm pretty sure that 1 megahertz should work, but we can lower it. Let's remove this change because that only makes it unclear because we don't see the error anymore. So we just remove the whole conditional. Let's remove this budget. I never have needed it before. Let's give it a moment. It should be plenty. That's weird. Let's see if there's something weird in our TOML file. Edit this. Or is it that I'm not running release? Let's check the documentation. Let's see what it says. Maybe I need to start it. Let's see. This doesn't seem to make a difference. Sensor. Start continuous. Not entirely sure what this means. I don't know, 100. And that's let's see. Yes. Well, at least one. That is odd. Because I tried this one before and that doesn't seem to exist anymore, so that is slightly different. But this one seems to help. So do I need to do that every time? Let's speed this up a little bit. Should that make a difference? Interesting, right? Now it measures again. So the distance it measured actually is the distance from the board here up to the phone, which is yeah, about 20 centimeter. So that seems legit. But why it seems to crash on the second loop is a little bit weird. Maybe add this one as well. Let's have a look at the GitHub. Are there examples? Not really. But there is someone, Chocolate Lover Raj, who did something. Let's see if they did something special. This is though for IDF, so that's that has a standard environment. So it might be a little bit different. Config is the same. Data clock. Yeah, and it should all be alright. 20. This is microseconds, so 20 milliseconds. Measurement budget. Start continuous once, and then I think he added the async layer. We'll get to that, but it should work. Maybe try this one. That's a lot of stuff. Well, I don't really see a lot of things we could have done wrong, and especially given that it worked before. And it seems to work, it seems to measure, so we can't have messed it up too badly. Maybe let's have a look. Yeah, it just should work. This shouldn't be in the loop, I'm pretty sure. Do we have any other things you could call? We could just do the read range millis. Not exactly sure what that does. So this seems to check if there is a result. If so, it will return that result, and otherwise it will just give an error. So let's try that. So then we need to do the thing we did before again. So we can, let's do okay. So we're converting the result into an option, and then we say some distance. So you're essentially ignoring the error now, but if there is a distance, then it will do this block. Let's see if that works. Super weird. And now it doesn't measure more than once, but it also doesn't panic, right? Like it did before. If I say stop and I say start again, I don't really know what this is actually. Maybe that's all wrong. Let's check what well, we'll try this and then we check what examples had for a value there. Okay, this seems to work. So yeah, we need to revisit that because I'm not happy with it yet, but let's see if we can influence the values a little bit. So if I pass my pen over it, see, raising the pen It's kind of finicky. So the pen is now a few centimeters above, and then when you remove it, it goes back to the bouncing off the phone. So that works kind of okay-ish. But this seems a bit dumb. To start it and start every time, and then it seems to do the thing. Yeah, the what do you pass into set start continuous is a bit of an open question. Start. It just says 0. Would that be the trick? Just say 0 and then remove these two. Yeah, now it works. Okay, so the trick is just to give 0 there, and then it will just work. So that is nice. So now we can measure distances. The downside of what we've done right now is that measuring distance is now all this chip is doing. And that's usually you have other stuff to do. Maybe you want to send the message somewhere, or you have more than one sensor, or somewhat. So we would like to use asynchronous, so we can do this and other stuff. Also, yeah. So we would like to use async, and that complicates stuff a little bit, as it tends to in Rust, but it's not impossible to overcome. But I think this is about a nice length to figure this one out, so I'll do a next one, because it's quite a bit more code for async. So thank you for hanging out and playing around with the hardware. Please leave a like. I like those, even though I'm not monetizing anything or something. But see you around, and take care.